So today we will discuss the hybridization. But before moving to hybridization, we will discuss that what was the actual need of hybridization. Like before hybridization, there were other theories as well. Like the first was Lewis theory, right? Then there was VBT, which is known as valence bond theory, right? And after that there was a concept of hybridization, and after that there are two more theories too, like hybridization got rejected as well. Right, so today we will discuss the hybridization, but let us discuss first according to the VBT, like what actually VBT states. I would I would try to make a video on VBT as well in order to clear your concepts, but until now you can understand the basic concept of VBT by this video, right? So let us first of all make the structure of CH4, like which is methane, right? Methane by the help of VBT. So what's the structure of methane? It's C H H H H bonded, and this is a sigma bond, right? The sigma bond over here, right? So let us first see the configuration of carbon, right? So we know that the atomic number of carbon is 6, right? So here 1s2, 2s2, 2p2, right? So now let's make the orbitals over here. So this is right here, one electron up clockwise, other anti-clockwise. Sorry. Right, so you can see over here that the 2p is already filled, right? It is filled, and the 2s is also filled. So like how, sorry, according to Hund's rule, we will fill them according to the Hund's rule. Like what was the Hund's rule? That we will fill the orbitals with one by one filling, right? So you can see over here there is just valency of 2, there is valency of only 2 over here, but here carbon is forming 4 bonds, carbon is forming 4 bonds. Like how this is, right? So obviously in order to increase its valency, it will go in its first excited state, right? It will go in its first excited state, first excited state, right? It will go in its first excited state. What will happen over here? This one electron will be moving to this orbital, right? It will move to this orbital, right? So what will happen now? This is s orbital, right? Now this, right? Now what will be happening? There will be one electron, one electron, one, and this is known as p, 2p, basically 2p, right? So as you can see over here, now it can form how many bonds? Now carbon can form 4 bonds, right? In order to form 4 bonds with the hydrogen. Now because over here there is just valency 2, so obviously it can't form, but over here there is a valency of 4, it can now. Now let us look at the valency of hydrogen 2, right? Okay, there how many hydrogen are there? There are basically 4 hydrogen. Let me remove this. Okay, there are 4 hydrogen, right? Now let us make the orbitals. Like we know the configuration is 1s1. Right? Now it will be like this. It will be anti-parallel because we know that always opposite spins will always combine together. Right? This is like this. And now this will be forming bond with this. Right? This electron will be forming bond with this. This will be forming bond with this. And this will be forming bond with this. So here there is s orbital, s orbital, s orbital, s orbital. But here s, it is s, p, p, p. So you can see that easily it is forming bonds. So we can write over here that over here the carbon is using s and hydrogen is also using its s. Over here now hydrogen will always use s because it's having only one electron in its first orbital, which is s, right? S. Now carbon has used its first s1. Now it will use its p1, p, and again p. Right? I hope this is clear to you. But now let's look. According to this, like how many types of bond are there, right? First one SS bond is there, then SP is there, then again SP is there, then SP is over there, right? Now basically what according to VBT, like there are 2 types of bonds over here, right? One is this SS1 and other is this one, right? SP. So it means that their bond energy bond length must vary. Like it must vary, it must not be same, right? So it must not be same, it must vary, it must be changed basically. But what happened that when we did chemical analysis, right? When we did analysis and according to some experiments, it was proved that all bonds have same energy. They are having same energy, same bond length, right? Now how it can be possible if VBT is saying that like there are 2 different bonds, right? There are 2 different bonds, so they must have different energy. Like SS will be having less energy and SP will be having more energy. Then how it is possible that there are same energy or same bonds bond length over here, right? So it means that here the concept of VBT was rejected. VBT got rejected, and this was the point where this was the birth of hybridization. Like this was the birth of hybridization, from where the concept of hybridization arised, right? By this it arise, right? So I hope the birth of hybridization is clear to you, like why hybridization was introduced. Because the VBT was rejected because it was stated that all bonds have the same energy, same bond length, but according to VBT they have different bond energy and bond length. So in my next video I'll be discussing about the hybridization, right?